Hi, this is Mike with Kids and Dragons, and I wanted to make a video today about morphs. I'm going to stay away from color for the most part today, and I'm really going to focus on the morphs in bearded dragons. So with bearded dragons, you have recessive morphs, and you have co-dominant morphs. And it took me a very long time to figure out the difference and how the morphs work or whatever, but when you get the hang of it, it's pretty easy. So basically, a co-dominant gene is one where you have a visual, and when you pair that visual to one that isn't a visual, half the babies are going to be visual for that morph, and half are not going to be visual for that morph. So you just need one parent who carries a co-dominant gene to pass that to half the offspring. Now with a recessive gene, both parents have to carry a copy of the gene to pass it to offspring. And a recessive gene can be carried visually, or it's called het when they carry the gene but you don't see any visual markers for that gene. So both parents have to carry a recessive gene to see it in the offspring. And the percentages change. The percentage of offspring that actually visually display the gene changes whether the parent carries it as a het but doesn't show the visual markers, or if the parent is a visual. And so I will go ahead and I'll start with probably the most popular morph, which is hypo. And I'll pull one out and I will just talk through what the morph looks like. Okay. So here we have a hypo. Typically these animals are pretty bright just at first glance on this animal. And the easiest way to tell if an animal is a hypo is that they have clear nails as opposed to the normal colored nail, which is black or a dark brown. And I have one that's similar, so you can see, and you can see immediately the color difference, how dark this animal is compared to how light this animal is. And both of these are from a red cross. So that is the kind of a crazy color difference. And you can see those nails are very dark compared to these, which are very light or clear. So the next morph I will talk, so hypo is it's a recessive morph. So both parents have to carry a copy to pass that to offspring. That's how hypo works. It's recessive. And so the next morph I'll talk about is the translucent gene. And this is a translucent animal. Now translucent animals, this female is also hypo, so she is a hypotranslucent. And the two genes together, they make very impressive looking animals. They're very bright usually into adulthood, and they really just get better and better as they age. The translucent gene you can tell it's a translucent because they typically have a transparent look to the skin, so self-explanatory, and they usually have black eyes. And now, this is something that I hear quite a bit. Translucent animals do not have to have black eyes. The easiest way to tell is because the skin, people say it looks gummy. Almost just has little parts of it that are not see-through, translucent. But they don't always have black eyes. Sometimes they have normal eyes. And a lot of times as a translucent is developing, you'll notice that after a shed, their eyes will be normal looking all of a sudden. And you're like, what happened to my animal's black eyes? And then the next time they shed, they could be black again. And it's a hit or miss with the translucent. Sometimes they stay normal, sometimes they stay black. Which brings me to another point to make. I've seen the term floating around for years, partial translucent, and I'm not trying to bash anybody, but I personally don't believe that it's a thing. It sounds like somebody's trying to make it seem like it's a different kind of gene, but it is the same exact gene. It is a visual translucent animal. There's no such thing as a partial trans. They either are or they aren't a visual translucent. And if it's a partial trans, which is a visual, it's going to work the same way. So you would never be able to breed that. You should never breed that to another visual trans and treat it any differently than a visual translucent. And I'm going to pull out a baby too to show you guys also. This little baby here isn't shed, but you can see that it has black eyes also. It's a little feisty thing, gonna get me. But another big indicator on the translucents is they have a very cool look to their belly. It's very blue. You can really see inside there, and you can see as they get into adulthood, they kind of lose this as their skin thickens up, and it just looks like a normal belly there. So let me see. That's another recessive morph. And so what's next? We'll keep with the recessives. So the next one I have here is a 0. So this is a 0 bearded dragon. And you know what? I'm just going to pull out a wit because I think they're good. It's good to look at them side by side. You can see the difference easier. But now these are two different recessive morphs. They're not compatible with each other. They are both considered a patternless mutation. And basically, the biggest difference right off the bat visually, you know, is a 0. And an easy way to remember it is they have 0 color. It really doesn't matter how colorful the parents are to the 0. They pretty much always come out like this, very colorless mutation. A lot of times a 0 will hatch actually with a pattern, a typical bearded dragon pattern on the back. They look like colorless, but they have that pattern, and usually after a shed or two it fades, and then they end up just like this completely patternless morph. And then with the wit, perfect timing, they hold the color a lot more than the 0. Again, completely uncompatible, completely different recessive morphs. So when I say uncompatible, I mean that you can't breed a het wit to a het 0 and produce patternless animals. They would both be, they could both potentially carry het wit and het 0 if you were to breed them together. So you can breed them together and produce what people call a wiro, which is visually both animal. But independently not compatible as a mutation. They're their own thing. Both very, very cool animals. So if you were working with a wit that didn't have as much color, because sometimes they can be extremely hard to tell the difference. Sometimes you could be working with like a white line wit where it looks very similar to this. And so a good way to tell the difference is typically 0s, they keep some of this dark back pad right here. You can see it typically stays a bit more dark than the rest of the body. And on the wit, it does not. It usually blends all into one color. So that's one easy way to tell the difference between the two. Trying to open that pad up so you guys can see it. But yeah, you can see that there's no black color on the pad like there normally is. It's just the color of the body. So as a general rule with the bearded dragons, it's a good idea to not breed visuals of a recessive mutation together to produce more. And it's simply because these genes have not been outcrossed enough to create healthy, long-lasting bearded dragons. Your best bet when trying to recreate these is to use hets. I would argue that in some cases you can breed a visual trans to a het trans, as long as that animal is perfect by standard. But for the zero and for the wit, I would definitely use visuals to make hets and hets to make visuals. So to be even more clear, I would never breed a visual zero to a het zero to produce zeros. I would never breed a visual zero to a visual zero. You are asking for trouble going down that route. I've never personally bred trans to trans, but I have purchased plenty of dragons in the past before I knew any better that were from trans to trans pairings, and they have so many issues. And I've never had one, honestly, I've never had one that lived longer than a year. Like they have so many problems as they get older, and so it's just not worth it. And the draw there, the reason that some people would do that is because when you breed recessive visuals together, all the offspring potentially could be that mutation. So a trans to a trans, all the offspring are trans. You're gonna have low eggs, not a very successful hatch rate, a lot of deformities. And like I said before, the ones that do make it, they live very unhealthy lives and they don't live very long. I honestly don't think I've had one live longer than a year. So that's why it's very important to use your het animals to make your visuals. And next we will talk about codominant genes. And I will start with the leatherback. So here's a leatherback, and I will pull out that very first hypo just so you can see visually the difference in the scalation. So a leatherback really has a reduced scale all over its whole body. Very smooth to the touch. It's a very cool mutation to work with. I love the way it makes tigers look. The leatherback is an awesome gene to work with. And this is the codominant mutation again. So that means if I breed her to a normal scale, half of her babies will be leatherback. It's not always exactly half, but those are the percentages.
What about a leather to a leather?
A leatherback to a leatherback. So that creates the super form of a leatherback is a silkback. And a silkback is a dragon that has no scales on its whole body. I've seen some that do have some scales on the tail, and I've seen people be like, what is wrong with my silkback? And it's some scales that ended up passing to those dragons. But yes, a leatherback to a leatherback produces 25%, I believe is what it is, will be silkbacks. And that's the super form. So what I mean by super form is if you were to breed a silkback to a normal scale, all the babies should be leatherback, in theory. So next, and probably, it's probably one of my favorite morphs, I would say, is the dunner. So this is a female dunner. She's a hypo. And so dunners have quite a few differences with this mutation. First of all, I think the easiest way to tell a dunner is that instead of bars that go across, they go down vertically like this. And I'm gonna pull out another tiger. And basically, if this dunner wasn't a visual dunner, she probably would look a lot like this dragon right here. So you can see the bars are clearly broken up and they go across the back here. Dunners typically have like larger hands. I don't know if you can tell on this or not. Doesn't really look like it. I don't know if that's a good difference to me.
A little bit.
Dunners have beard scales that go pretty much in every single direction, not just down, like this just goes down, and you can see the beard scales just kind of, they're crazy. The thing I love about the Dunners is...
The scales on their tail and everything, they're just extra spiky too. Yeah,
if you look at the scales on the tail also, they just go in every direction as opposed to uniform. The thing I really like about the Dunners is they just have a more wild, just kind of like wild, outdoorsy, like you would think it belongs outside, running around outside kind of animal. Also, another difference, and it is a bit harder to tell on this female because she's very light, but the circles on the tail also, they're broken. They're not like this. Like even though she's light, you can see they're well-defined circles that go all the way around the tail. They're always broken on the Dunners. So a lot of the times that's really cool looking, especially on baby Dunners. They'll have like crazy stripes that just go all the way down the tail. Okay, and so the last one I'm going to pull out, and I hesitated even pulling this dragon out because I'm not really, I go back and forth on whether it should be called a morph or not, but this is not a zero, this is a paradox. And so a paradox bearded dragon essentially is a dragon that her color typically would have been like this orange color you see in speckles here. That is probably how this dragon would have looked over the entire body. It should be that color. And so what happens in paradoxes is they lose it. They lose their color, they gain this kind of gray splotchiness, and you have all different kinds of variations of paradox. Sometimes they'll get just some minor paradoxing on the tail or the beard. Sometimes it's their head. Sometimes it's a spot or two on the body. This female is a very high expression in the way that her entire body lost its color, and then it kind of gained back these splotches of what her body color should be. Now, a lot of people believe there is no way to reproduce a paradox. Okay, so a lot of people don't think you can reproduce a paradox, and I kind of am on board with this, kind of not. I'm a little bit in the middle. But I'm a pretty strong believer that there are things you can do to increase your odds of potentially producing a paradox. It's a project I've had. It's always been kind of a smaller side project for me. I know I share a lot of pictures, so it probably seems like it's always been a focus. It's always been a small part of the projects I work with. And it's a lot of fun to work with them because it's just kind of like you raise up all these babies and you watch them and they can change at any time. And so you're just constantly watching babies, and then when you see one make that change, it's so much fun to work with them. But yeah, as I was saying, there's things you can do to increase your odds of potentially producing one, but there's no guarantee with the paradox, which is a level of funness to it that not a lot of people can reproduce them. Not a lot of people do reproduce them, so it's fun to kind of like play with it and see if you can. But I would never do trans to trans, which I know is a very widely known thing that people have done in the past in order to recreate a paradox. Usually animals you see that are paradox are hypotrans animals. And you can even see that this female is not a trans, which is even more rare. Usually they are hypotrans animals. And I think that's why people believe that breed trans to a trans and you'll get it. I don't think that increases your odds. As I've already said, and I'm gonna say it again, I think you're in for it's gonna be no fun when you hatch that clutch out and half of them hatch, and the ones that do hatch, half of them are deformed. None of them are paradox. It's just not gonna be something you'd want to do. So I'm not going to get into actual breeding in this video and what to do to increase your odds. But there are things you can do to increase your odds. It is not trans to trans. I would never personally do that. Okay, so I didn't talk about color phase in this video, which is completely different. A lot of people bunch it together. Color is very different than morphs. These are the morphs. They're, you know, there's a little variation, but I mean, they're percentaged out. Like, you pretty much know what you're gonna get. When you have a basic understanding of genetics, you pretty much know what you're gonna get when you're working with recessives and codominant morphs. Color is a different animal, and so you have your reds, your oranges, you have your patterning with G stripes, tigers, color stripes. And I'm probably going to make a video talking about color and pattern and those kinds of things, because it's completely separate in my opinion, so I'm not going to bunch it together. So I hope you guys learned something from this video, and I hope everybody has an awesome rest of your day. Bye-bye.